tests of the 1953 Upshot-Knothole series. This was 26 kilotons at a height of burst of 2,500 feet. The lines of smoke seen in the background are rocket trails which are used for measuring free air pressure from the explosion. The camera is at 12,000 feet, and you will shortly see the shock wave as it arrives at this point. Now, if you look closely at this next scene, you will see the blast wave moving across the screen. Now, note the dust that is kicked up by the blast wave. While this is appreciable, it is by no means as much or as high as it is from shot number 10, which you will see in a later view. This is a long-distance view of the forest stand for shot number 9. You notice that the thermal phase of the explosion is causing smoke to come from the trees, but no fires are started. This forest stand was at a distance of 6,400 feet. The pressure at this distance was 4½ psi, and the thermal flux 18 calories per centimeter. Approximately 35 out of the 150 trees in this stand were knocked over by the blast. This is a close view of the same stand. Measurements indicated that the drag pressure decreased as one moved into the stand, thereby indicating some shielding influence from the trees in the front part of the area. This is an F-47 at a distance of 3,000 feet. This plane was tied down. The pressure was 11 psi, and there was 60 calories per square centimeter. This plane is another F-47 at 5,900 feet. 5 psi and 21 calories per square centimeter. This was covered by an aluminum cloth to provide protection from thermal radiation. Tests showed that it is the combination of thermal radiation and blast which is critical in producing damage to parked aircraft with this size weapon. The next pictures are some houses which were exposed in order to study the ignition of fires from direct thermal radiation. The building on the right had old wood and a large amount of trash and old clothes lying around. The building in the middle had no trash and was freshly painted with white paint. The building on the left also had no trash, but had old, rotten wood. You will notice that the building that had the trash and was unpainted caught fire very rapidly and was completely destroyed. The building which was unpainted but had no trash caught fire more slowly, but eventually burns, while the freshly painted building, which had the area around it cleaned up, did not burn at all. You are seeing here 3 seconds out of each minute. A similar experiment, which will be shown in the next scene, involved the possibility of starting fires in interiors of houses. 2 similar houses were placed side by side with the windows facing the point of detonation. One house had ordinary living room materials inside, which were subject to flame and ignition, while the other had relatively insensitive materials. The one with the sensitive materials caught fire immediately, while the other building remained untouched. These two experiments combined pointed out very graphically what can be done in order to reduce the incidence of fires from direct thermal radiation. This is a Bailey Bridge, also on Shot 9. It was a distance of 4,100 feet. The pressure was 8 psi. You will notice that the bridge moves and then comes back a slight distance in the negative phase of the blast wave. A similar bridge on Shot 10, at about the same pressure, was picked up and thrown 40 feet by the blast. This is a rather graphic comparison between the blast from Shot 9 and Shot 10. This is a signal corps radio tower, which was 120 feet high. It was at a distance of 3,200 feet, where the pressure was about 10 to 11 psi. This was a combined FCDA Air Force experiment to study the resistance of different types of curtain walls to blast. There were a large number of these curtain walls, only two of which are being shown here. In this particular picture, both of these walls are blown in. The pressure at this distance, which was 4,400 feet, was 7 psi. Here is a rear view of the same panels. You will note that although both panels were blown in front, only the panel on our left failed in the rear. This is an experiment conducted by the Air Force to test different types of roof panels. This particular experiment was at 6,700 feet and 4.4 psi. This is one of the many quartermaster POL dumps exposed on Shot 9. The cans were tossed around to a great extent, but very few of them were broken up. No fires were started, and there was little damage even relatively close to ground zero. This is a test using pigs to determine the protective effect of clothing. It was found that 2 or more layers of clothing will provide a very high degree of protection from thermal radiation. This particular station was at 5,700 feet, and the exposure was 22 calories per square centimeter. This was one of 3 field hospital installations which were exposed at different distances. This particular station was at 15,000 feet from ground zero, where the pressure was about 1 psi and the thermal level about 1 to 2 calories per square centimeter. There was no burning at this distance. The shadow caused by the upward passage of the blast wave through the sunlight can be seen now. The blast wave itself takes quite a long time to arrive, and did succeed in blowing down the tents, but the damage to equipment inside was relatively minor. A similar installation at 5,000 feet was completely destroyed. This is a larger POL tank that was actually filled with water. The particular tank was at 9,200 feet, where the pressure was 2 1/2 psi. Although the top was blown in, the damage to the sides was negligible. This was true of all the POL tanks, even relatively close to ground zero. Military vehicles exposed on Shot 9. These particular vehicles were at 4,300 feet, where the pressure was 7 1/2 psi, 35 calories per square centimeter. As soon as they were righted, they could have been driven away. On this shot, even at 500 feet, the damage to the vehicles was relatively small, even though they were overturned. This is the fireball from Shot 10, which had a yield of about 15 kilotons and a height of burst of 520 feet. Note the double fireball. This is believed to be caused by the reflected shock wave blowing a hole back through the fireball as it went up. Because of the low height of burst on this shot, the thermal radiation was sufficient to create a hot air layer close to the ground, which in turn provided a means for forming the so-called precursor pressure wave. Looking at the photography of the blast waves in the following shots, one will notice that there are two pressure waves seen moving out along the ground. The first of these two pressure waves is the precursor. Notice the tremendous amount of dust which is kicked up behind the precursor. Here you will see the precursor and the initial wave. Again, notice the tremendous amount of dust which was kicked up, very much more than is kicked up by an ordinary shock wave. On this shot, the damage to drag-type targets in the region where the precursor occurred was very much greater than had been predicted. Vehicles were completely destroyed at a pressure of about 10 psi, as compared with little or no damage at 20 to 25 psi on the previous Shot 9. This shot will show the precursor very well. You'll see the two blast waves moving along, one behind the other. Here they come. Now. Again, notice the tremendous amounts of dust. Here are some of the missiles which were thrown around on this shot. Parts of vehicles, trucks, and guns. The amount of debris which was scattered around was simply terrific. And here, so far as we know, is the first authentic flying saucer to be photographed. This is at a greater distance, beyond the point where the precursor has reached. You will notice that the dust is not nearly as great at this distance as it is close in. The terrific dust is directly connected with the precursor formation. This is an unloaded railroad boxcar at a distance of 4,400 feet, where the pressure was 4 psi and the thermal radiation 23 calories per square centimeter. You can see that it was knocked off the rails and essentially destroyed. This is a loaded boxcar at the same distance. In this case, although kindling was knocked around to a great extent, the boxcar did not fall off the rails. This is a tank which was exposed as part of the desert rock layout. This was at a distance of 4,400 feet, where the calorie level was 23 calories per square centimeter, and the pressure was 4 psi. It is interesting to note the combination of the thermal and the blast. This is an AAC civilian defense car, which was at 2,900 feet, where the pressure was 7 psi and 47 calories per square centimeter. This was a school bus at the same location. Note the tremendous burning from the thermal radiation and the blast wave which turns the car over. When the dust cleared away, the bus was found to be standing in its original position, indicating that the negative pressure wave had turned it back up again. This was one of the many window glass experiments. This is high-speed photography, 2,500 frames per second. And you will notice with these jealousy-type windows which have hinges, in one case the hinge was too tight and the glass broke, while in the lower pane the window hinged rather than the glass breaking. This would have provided some protection to people inside. The next 3 shots are scenes of the blast wave from the 11th shot. This was a 60 kiloton weapon with a height of burst of about 1,350 feet. This next shot, if you look very carefully, you can see the precursor and the reflected shock waves very clearly.